All right, let's talk about the one thing that separates the good automation engineers from the truly great ones. It isn't just about writing tests that pass today. Nope, it's about architecting a framework that's still standing strong years from now. Let's dive in.
Come on, we've all been there. You spend weeks, maybe even months, building out this beautiful test suite. Then, a developer makes one tiny little change to an API and, boom, your whole dashboard lights up red. It's frustrating, it's slow, and honestly, it makes your automation feel like more of a problem than a solution. But what if I told you there's a much, much better way?
You know, the root of the problem really boils down to this choice. On one side, you've got the spaghetti code method. It's chaotic, tangled, messy. Every test is somehow connected to another. But on the other side, you have the architect's blueprint, a structured, planned, and rock-solid approach. Today, we're handing you that blueprint.
Now, before we start building, we need to be crystal clear on what we're trying to avoid. So let's shine a light on the classic signs of a framework that's caught in the unscalable trap.
This is what that trap feels like. One small test failure triggers a massive domino effect, and suddenly hundreds of tests are failing. Your maintenance costs go through the roof because changing one tiny thing means you have to go hunt it down in like 50 different scripts. Running tests in parallel? Forget about it. It's impossible when everything's tangled up. And trying to switch from your dev environment to staging, well, that becomes a full-blown crisis of finding and replacing hard-coded URLs. It is a total maintenance nightmare.
So, how do we escape this trap for good? Simple. We stop thinking like we're just writing one-off scripts, and we start thinking like architects. We need a solid blueprint.
This quote just nails the core idea. Seriously, think about your framework like a library. Your test logic, your test data, your configurations, they're all in separate, clearly marked sections. Need to update some test data? You just swap out a few books. Need to point to a different environment? You just update the library's rules. You never, ever have to tear down the walls and rebuild the whole thing.
And visually, it kind of looks like this. The foundation of our entire structure, that's our configuration. All our base URLs, API keys, credentials. The individual rooms in the building, those are our test cases, each one totally self-contained and independent. And the wiring and plumbing that connects everything together, well, those are our reusable utilities, the shared code that does all the heavy lifting for us.
This whole blueprint, this entire philosophy, it stands on three foundational pillars. If you can master these three, you're going to be in fantastic shape.
Okay, pillar number one is modular design. This is a simple but incredibly powerful idea. It's all about breaking everything down into small, reusable, independent pieces. That means no more copying and pasting the same 20 lines of authentication code in every single test you write.
And here's the real pro move, an insider tip from the top 1% of engineers. They are obsessed with separating what they're testing, the business logic, from how they're testing it, the nitty-gritty technical details. They abstract away all those common actions, like generating a token or validating a status code, into these neat, reusable helper functions.
Pillar number 2, configuration management. This one's a biggie, but the rule is simple. Get your environment-specific data out of your test scripts. Base URLs, API keys, database passwords, none of that stuff belongs in your test code. It all belongs in an external config file, period.
And here's why this is so critical. When you pull your configurations out, you gain this incredible flexibility. You can point your entire test suite from the dev server to the staging server, or heck, even to production, just by changing a single value in one file. No code changes necessary. For your CI/CD pipeline, this is an absolute game changer.
And our third and final pillar is test isolation. This means every single test has to be its own self-contained universe. It should set up its own data, do its thing, and then ideally clean up after itself. No test should ever depend on another test running before it.
And this quote is the absolute truth. Strict test isolation is completely non-negotiable. It's the only way you can confidently run your tests in parallel and get that super fast, reliable feedback you need from your pipeline. Without it, you're really just building a house of cards that's waiting to fall over.
All right, that's enough theory. Let's see what this blueprint and these three pillars actually look like inside a real project structure.
A really well-structured project physically separates these different concerns. See here, you've got a test package just for your test logic, a utils package for all your reusable helper classes, and a resources folder for your configs and test data files.
And this isn't just about being tidy. This structure actually enforces modularity and makes the project instantly understandable for anyone new joining the team.
And check this out. This is a perfect example of modularity in action. Instead of setting your base URI and headers in every single test, we create one utility class like this, API config. This one method, getDefaultRequestSpec, it centralizes all of that logic. Now, if the base URL changes or you need a new header, you update it in exactly one place. That right there is the power of reusable components.
Now, understanding these principles is one thing, but putting them into practice means you have to actively avoid some really common bad habits. So let's contrast the typical rookie mistakes with the pro moves.
You see the pattern here, right? The rookie hardcodes values all over the place. The pro uses config files. The rookie chains tests together, creating a fragile mess. The pro isolates every single test. The rookie stuffs test data right into the script. The pro drives their tests with external data. Every single pro move is about creating separation, independence, and flexibility.
Okay, let's bring this all home. If you really want to build a framework that lasts, what's your mandate? What's the mission?
It really all boils down to these three things. Seriously, burn these into your brain. Modularity makes your life easy when it comes to maintenance. Isolation is what gives you raw speed through parallel execution. And external configs, they give you total control to run your tests against any environment, anytime. And I am not exaggerating here. If you truly master these three principles and apply them from day one on your projects, you are immediately putting yourself in the top tier of automation engineers. You'll be building valuable assets, not brittle liabilities. I want to leave you with this one final thought. Don't just build to solve today's problems. Think ahead. Anticipate growth. Build the framework for the complex, sprawling application that your company is going to have in 2 years. That is the true essence of scalable design.
Hey, thanks for watching. In our next explainer, we're going to build directly on these concepts. We're going to dive deep into advanced test data parameterization, taking that pro move of data-driven testing to a whole other level. You are not going to want to miss it.